Hi, the name of this Blender video tutorial is Basic Blender Particles Part 1. Blender particle systems are used to simulate large amounts of small moving objects, usually creating ephemeral phenomenon like fire or dust or clouds or smoke, or stranded-based objects like fur, hair, or grass. In this tutorial, we'll look at how Blender particles are generated. In the next video tutorial, we'll examine what they look like when rendered. To demonstrate Blender particles, I've placed a plane object in my Blender scene. I'll select the plane object and go to the Particles editor and click on the plus button, which will create a new particle system for the plane object. By default, the name of this particle system settings is Particle Settings. I will change this to Demo 1. Note that I am not changing the particle system name, but the name of the particle system settings, its unique data block. The particle system type is by default emitter. If I click on the type box, you can see that Blender has two particle system types, emitter and hair. I will select the default emitter type. The hair type is covered in a later video tutorial. The seed setting is a collection of defined random bases from which the particle system is constructed. This allows the randomness settings inside of a particle system to be identical over repeated timeline animations. By default, once an emitter particle system is associated with an object, particles are emitted from that object based on the particle system settings over the animation timeline period. I will change the endpoint of the timeline from 250 to 100 frames. I'll play the animation. As you can see, particles seem to be emitted from the face of the plane object and appear to fall through and flow down the z-axis. In the Emissions panel, under Emit From, the default is set to Faces. I will change this to Vertices. The particles now appear to be emitted from the plane's vertices. Emit from volume is much like emit from faces, identical in fact when using a plane object, as the emission is from the enclosed volume of the object. I will go back to face emitting. The number of particles emitted over the course of the timeline is set by default to 1,000. This means, in this particular case, that 1,000 particles are emitted over 100 frames. Or another way of saying that is that 10 particles are emitted on each frame. I will change the number to 100. Now, 1 particle is emitted each frame. I'll change this to 10,000. Now, 1,000 particles are emitted each frame. By default, the particles start to be emitted on frame number 1 and continue to be emitted to frame 200. Since our timeline is only 100 frames long, particles are emitted the entire length of the animation. I'll set the end emission to frame 50. The particles begin to be emitted on frame 1 and stop emitting on frame 50. The lifetime of each particle is set by default to 50 frames. Thus, particles emitted on frame 50 live to the end of the animation on frame 100. I'll set the lifetime to 25 frames. Now particles emitted on frame 1 disappear or die by frame 25. And particles emitted on frame 50, the point I set to end emitting, disappear or die by frame 75. I'll set the number of particles to 2,000, or 200 per frame. I'll set the end to 100, and the life to 100. Particles now emitting on frame 1 live the length of the timeline animation, 100 frames. Thus, the length of the particle trail is quite long. The random slider in the emissions panel adds an element of a random lifetime to the particles. The higher the setting, the larger the percentage of particles that will have a random lifetime. I'll set the random controller to 0.5. Now, half of the particles being emitted have a random lifetime, and the other half have a defined lifetime of 100 frames. Thus, only one half of the 200 particles emitted on frame 1 live to frame 100. The reason the particles seem to be emitted from the plane's face and then drop down along the z-axis is because by default the particle system is regulated by Newtonian physics. This is the default button setting in the particle system in the physics panel. It is the normal particle physics. With Newtonian physics, particles start their life with a specified initial velocity, an angular velocity, and move according to forces. I'll press my R key and rotate the plane object a bit. The particles are still emitted from the face a bit, but then fall down along the z-axis as gravity overtakes them. In the physics panel, I will select the No Physics button. Now the particles are not affected by Newtonian gravity and scatter about the surface of the plane. I'll go back to Newtonian physics. I will also set the number of particles in the emissions panel down to 100. Particles can be affected by other objects. I'll stop the animation timeline, and then I'll press Shift-A and snap my 3D cursor to the plane object's origin. I'll then add another plane object. I'll scale it up a bit, and then move it down along the z-axis. I'll then select the emitter plane object and play the animation timeline. Particles are emitted from the normal face of the emitter plane object, then fall down along the z-axis due to gravity, and pass through the second plane object. I'll select the second plane object, and then go to the physics editor and add a collision modifier to the object. Now the falling particles bounce off the second plane object. I can dampen the effect of the particle bounce by adjusting the particle damping factor in the collision panel on the second plane. I will set this factor to 0.7. Now the particles have little bounce and just tend to roll about the second plane. I'll rotate the second plane a bit. The particles bounce a little on the second plane and then roll off to the side as gravity overtakes them. Blender provides a wide variety of particle interaction. The force that pushes the particles from the plane's normal face is called the particle velocity, and by default this is set to a value of 1 in the velocity panel. I will change the normal velocity to 10. The particles are now emitted from the face up along the plane's normal direction much farther, and then, overcome by gravity, fall back down along the z-axis. This initial velocity is indeed in the direction of the plane's object's normal. If I rotate the plane object, note that the particles are still emitted into whatever direction the plane's object normal face is pointing. I can counter somewhat the effect of gravity by lowering the lifetime of the particles so that they die or disappear around the same time as gravity takes over the normal velocity. I'll lower the lifetime to 25 and set the lifetime random to 0.3. The particles appear to be constantly flowing from the face normal throughout the animation and die around the time gravity takes over their direction. This works even if I rotate the object. Although Newtonian physics is the default physics setting, it is possible to make the entire scene unaffected by gravity. This setting is located in the scene editor. Here is a gravity panel which sets the global gravity for all scene dynamics. If we uncheck the gravity box here, our particle system, in fact, all particle systems in the scene will not be affected by gravity. I will uncheck gravity. Note how much higher the particles are now reaching perpendicular to the plane's face normal, because the particles are no longer affected by gravity. I will rotate the plane object. Currently, the particles are being emitted from the face of the plane object along the face normal. To demonstrate how this works with multiple faces, I'll go to Layer 2. Here I have a circle object that I have extrude scaled to form 16 faces. I'll go to the Particles panel and click on the plus sign to assign a new particle system to the circle object. Now I could create a new particle settings here, but Blender allows the setting from one particle system to be linked to multiple objects. I will click on the Browse Particle Systems to be Linked box and select the Demo 1 system that I set up for the plane object on layer number 1. Note that the particles are being emitted from the emitter's face normal, but some of the particles are being emitted downward. This is because in the process of extrude scaling the circle object, one of the circle faces was flipped so that the normal side faced down. I'll tab into Edit Mode, select all of the vertices, and click on the Recalculate Normals button in the Tool panel on the left. This makes all of the circle face normals point upward, well actually outward, in the same direction, and thus all of the particles are now being emitted in the same direction. With face emitting selected in the Emissions panel, particles can be emitted either uniformly, with even distribution, from the faces, or randomly, random distribution from the faces, or both, which is the default. In the Emissions panel, I'll select only even distribution. To see this more clearly, I'll set the face normal velocity to 1. Remember, we currently have gravity turned off in this scene. And I'll set the particle lifetime to 100, the length of the timeline. Number to 64, or 4 for each face, and I'll lower the random emission to 0. Now, with even distribution, over the course of 100 frames, each face emits 4 particles, one face after another. I will uncheck even distribution and checkmark random distribution. Now 64 particles are emitted over 100 frames, but the distribution across the faces is random. By default, the jittered button is activated. This means that the actual point on each face that the particle is emitted is a bit different on each face. Random means that the emission point on each face is random. I'll select Grid, then checkmark Invert Grid. The particles are generated in a grid-like structure. I'll go back to jittered. I will also increase the number of particles to 1,000. With gravity in the scene turned off in the scene editor, and the normal velocity set to 1, the particles are emitted up along the circle face normals. Instead of being emitted along the face normal, it's possible to emit the particles in the X, Y, or Z directions. I'll set the normal control to 0 and set the X control to -1. The particles are now emitted along the negative X-axis. I'll set the X control to 0 and the Y control to 1. I'll set the Y control to 0 and the Z control to 1. Notice that these directional velocities refer to the object's local rather than global axis. I'll rotate the circle object a bit. I'll set the Z control back to 0. I will set the normal control back to 1. I'll stop the animation and go to frame number 1. Note that at frame 1, the particles are hardly visible because it takes some time for the particles to gain velocity and to move up away from the circle's face normal. In the emissions panel, I will set the start to -25. Now in frame number 1, the animation particles are already in motion. This is frequently used setting when you want the particle effect to be in motion on frame number 1 of the animation. I'll play the animation timeline. Like random lifetime and random distribution, there is also a setting in the velocity panel for random vectoring of particles. I'll increase this random vector to 1. This causes the vector, or projection angle from the plane normal, to be random and thus spread out. I'll return the vector random to a setting of 0. It's also possible to set the particle emission based on the object's surface tangent. I will set the tangent control to 1. Now the particles are emitted along the object's surface tangent. Note that the face that was originally created normal side down emits in the opposite direction because when recalculating the normal, the surface was flipped. I'll tab back into Edit mode, go to Face Select, select that face, and then click on the Flip Direction button in the tool panel on the left. Now the particles are emitted along the object's surface tangent in the same direction, away from the object. I will rotate the surface tangent completely around by setting the Rotate slider to 1. Now these are just some of the basic settings for generating an emitter particle system. In the next video tutorial, we'll look at how these particles appear when rendered.